Hi, today we're going to talk about arithmetic series for International GCSE exam. Let's proceed on.
Are you feeling confused? You have problems in math? Our online courses will help you at any time.
What's the nth term? Here is the nth term of the arithmetic series, which is an, or it can be Tn equals a1, which is the first term, plus n minus 1 multiplied by d, which is the common difference. D is common difference, which is what happens in the rule, it increases or decreases, and a1 is the first term of series, and n is the number of terms, or we can say it's the order of the term. If you want to get the nth term, so n is the order of the term, and a1 is the first term, and d is the common difference if the sequence is increasing by a specific rate or decreasing by a specific rate. For example, here if we have arithmetic sequence, the first term is 7 and the common difference is 4. So what you will do is you're going to keep 7 as it is, and then you will expand 4 on this bracket, so it's going to be 4n minus 4, and then you collect the like terms. So the nth term of this sequence is an equals 4n plus 3. So here we have an example for the nth term for arithmetic sequence, and here we have the rule of the arithmetic series. What's the difference between the series and sequence? Sequence, it has numbers that they go in, or they are increased or decreased in a specific pattern, but the series is the total of, or the sum of the numbers in this arithmetic series. So sum of n terms goes by using this formula, Sn equals n over 2 multiplied by 2a plus n minus 1d. As we have known before, n is the number of terms here in the arithmetic series, n is the number of terms, a is the first term, and d is the common difference. So if you are working on arithmetic series, you will use to get the summation or the total for the terms, you're going to use this formula, n over 2 multiplied by 2a plus n minus 1d. A is the first term, n is the number of terms, and d is the common difference. So the number of terms, first term, common difference. But here if you are working on arithmetic series, arithmetic sequence, this is the first term, order of the term, and common difference. It is a bit difference, or a small difference between the sequence and the series. Sequence numbers, they go in a pattern, but the series is the summation of the terms of the sequence. So let's see some examples from the past papers. The first example says here from the past paper, the sum of the first n terms of arithmetic series. So talks about the summation here. The second term of s is 8.5. The fifth term of s is 13. Find the value of n. Show clear algebraic working. So first of all, we have Sn because the sum of the first n terms. We don't know what's the number of terms. So we're going to use the formula, which is Sn equals n over 2 multiplied by 2a plus n minus 1 multiplied by d. This is the formula that we will work on. The summation or the total for these terms is 292. We need to know n. But here's a hint is given that the second term of s is 8.5, the fifth term is 13. So you must take care about the point that I'm going to mention now is the numbers, they go in a pattern by the first term is a, second term is adding common difference, third term is adding 2 common difference, fourth term is adding 3 common differences. So if you know this pattern, you will work very well on such questions. So the first term is a, second term is a plus d, third term is a plus 2d, then a plus 3d. So now it's mentioned that second term is 8.5. According to this pattern, second term is a plus d, fifth term will be a plus 4d, So here in this one, I'm going to mention second term will be a plus d, which is equal to 8.5, and then I have fifth term, which is a plus 4d. A plus 4d is equal to 13. The most important thing in this formula, you need to know the value of a, the value of d, and the value of the sum so you can get n easily. So how do we can get the value of a and b? You have now two linear equations or two simultaneous equations. You can work by solving, you can work on finding the value of a and d by solving these two equations together. Then you can get the value of a and b easily. Then you can get back to this formula and find the value of n. So by solving these two, we can get the value of a and the value of d easily. So it will be a plus d equals 8.5 over a plus 4d equals 13. Here you can work on substitution method by using substitution method, or you can work by using the elimination method. So it will be this one, we can do subtraction here. So it will be a minus a will be 0, so it's going to be negative 3d equals negative 4.5, so d will be 1.5. So d is 1.5. If you give back to one of these two equations by substitution, you can get the value of a by substituting here or here, it's up to you. So if you substitute here, it will be a plus 1.5 equals 8.5, so you can shift it there to the other side. So a will be the value of 8.5 minus 1.5, the answer would be 7. So now we got the value of a and we got the value of d. It's now the question becomes easier to you. You can work on finding the value of n by substituting these values there. So we can erase now this part or the hint that I gave you, the relation between the terms and the arithmetic sequence. So what we will do is we will do Sn here is 292 equals n over 2 multiplied by 2 by 7, the value of a is 7, then add it to n minus 1 d, which is 1.5, and then we will expand here, so we can just change this to write it properly as 7. Then let's do expansion. I will multiply by 2 by 2, so we can get rid of the fraction. We will do 292 multiplied by 2. It will be, the answer is 584, and here we have n, and here we have 14 plus, you can expand 1.5 on n minus 1, it will be 1.5 n minus 1.5, and then we will subtract the numbers in here inside the bracket. It will be 14 minus 1.5, it will be 12.5, and then plus 1.5n multiplied by n here, and here 584. So you just expand, it will be 12.5n plus 1.5n squared equals to 584, and then you will do multiplying. To avoid having the decimal, you can multiply by 2 for the whole equation. It will be 3n squared plus 25n, and then you take this to the other side and multiply by 2. 584 multiplied by 2, the answer will be 1168, but it will be in negative. 1168 is equal to 0. So now we got a complete equation in n. We will do factorization to get the answer for this one. After doing factorization, you're gonna find that there are two values for n. N maybe will be 16, and then n will be a negative value, I think 24 point something. So this will be rejected because the number of terms cannot be decimal and it cannot be negative as well. So you're gonna find at the end that the value of n is 16. So there were 16 terms. If we add them together, but if we substitute here in this formula, we'll get 292. So you can make sure by doing substitution on this. I will substitute in the equation before we factorize. It will be 3 by 16 squared, and then by 3, then minus 25 by 16, 25 by 16 could be 400 minus 1168. Okay, so the answer is correct. The value is 16. Let's move on for another question and see how do we do this one. Another question that says an arithmetic series has first term a and common difference d. The sum of the first two n terms of the series is 4 times the sum of the first n terms of the series. Find an expression for a in terms of d. Show you're working clearly. So we need to link what's given in here, and then we find at the end equation a is the subject and d is included, or a in terms of d. The question says the sum of the first two n terms of the series is 4 times the sum of the first n terms. So 2n, it means each n in the main formula would be replaced by 2n. So let's use the first formula, which is Sn. And suppose it's Sn equals n over 2. This is the original formula. And here we have 2a plus n minus 1 multiplied by d. But here I will use 2n instead of n. So S of 2n equals 2n over 2 multiplied by 2a plus 2n minus 1 multiplied by d, and here's the formula. This one is equal to 4 times of the sum of the first n, which is the original formula. So we can link these two by writing 2n over 2 equals to this one here, equals to, or sorry, it will not be equal, to be 2n multiplied by 2a plus 2n minus 1 multiplied by d is equal to 4 times 4 multiplied by n over 2 by 2a plus n minus 1 d, and here is the whole one. So now what we will do is we'll try to work on simplifying this equation. We will cross out 2 and 2 here, and then we'll have the original formula. It will be n multiplied by 2a plus 2n minus 1d. Here what you will do is 4 and 2 can be simplified, so this 2 will be 1, or it will be removed, and this one will be 2, so it will be 2 here. So we have 2n equals 2a plus n minus 1d. So what we will do now is we will cross out n from here and n from here. So what will be remaining in this part, it will be 2a plus, if you expand 2n minus 1 multiplied by d, it will be 2nd minus d equals to, here we have 2 only is remaining, so 2 will be multiplied by, first of all you can expand n by d and minus 1 by d, then 2 will be multiplied by everything inside, so 2 multiplied by 2a is 4a, and then we have nd by 2, it will be 2nd, and then we have minus d multiplied by 2, it will be minus 2d. So if you look here, you're going to find some of them, they are similar. So what you will do is you're going to cross out similar terms. Here this one and this one will be crossed out, and then we will collect a's in one side and the d's in one side. So it will be, I have 2 here, 4a, 2a will go there, so it will be 4a minus 2a is equal to here the d, so this one has been there and this one has been there, so it will be 2d minus d. 2d minus d. So it will be 2a is equal to 1d. 2a equals to 1d. So what we will do is we will divide by 2. So 2a equals d, then a equals d over 2 by dividing. So the relationship between them, that a equals d over, how do we solve? The question says the nth term of an arithmetic series is un, where un is greater than 0 for all n. The sum to n terms of the series is Sn, given that u4 equals 6 and that S11 equals u6 squared plus 18. We need to find the value of u20. So here is arithmetic series. We need to find the value of u20 by using the given info. So what we'll do is u4, as I mentioned in the arithmetic sequence, it's a, then a plus d, then, so let me remind you here, the pattern is a, then a plus d, then a plus 2d, then a plus, sorry, let's delete this. So again, the pattern goes as a, then a plus d, then a plus 2d, then a plus 3d. So the fourth term, u4, is a plus 3d, all equals to 6. So this is the equation that we will use and the coming points. Then we have S11 is u equal u6 squared plus 18. So mainly S11 is equal to what? S11, it means you replace n by 11, so it will be 11 over 2 multiplied by 2a plus 11 minus 1 multiplied by d. This is the S11, the value of S11. So let's simplify more. S11, it will be here, we have 5.5, because 11 divided by 2 is equal to 5.5, and then we will try to simplify as much as we can. So it will be S11 equals 5.5 multiplied by 2a plus, we have 11 minus 1 is 10, so it will be 10d. Then, so if we expand more, it will be S11 is 5.5 by 2 is 11a, then plus 55d. This is S11 according to the main rule. But now it's given that S11 equals u6 squared plus 18. So let's find the other form of S11. S11 is u6 squared, which is a plus 5d all squared added to 18. So S11 will be a squared plus 25d squared, and then we have a by 5 as 5ad plus 2. It will be multiplied by 2, it will be 10 10ad, and then we have plus 18. So what we will do is let's write this properly, ad, and then here, so it will be 25. This is 25d squared, 25d squared, and here is squared, and here ad. So I will try to simplify as much as I can, or we can use the equation which we wrote at the beginning, that a plus 3d is equal to 6. We can make a as a subject, or we do substitution, a in terms of d. So this equation can be written as a equals 6 minus 3d, and then we would work on this one and the rest of the equations to solve this question in easier way. So I will do what? I will replace here each a by 6 minus 3d. Then we can solve this one easily, but let's write this one properly. So it will be here, to write this one properly, it will be a here, here a, d, and here is squared. So replace each a, so S11 will be a squared, which is 6 minus 3d squared, 6 minus 3d all squared, and then we have 10 multiplied by 6 minus 3d d all by d, then plus 25d squared plus 18. So we're gonna have a complete equation in D for this question. So it will be here, by expanding this, it will be 36. So S11 can be written as here 36 plus 9d squared minus 3 by 6 is 18 by 2 is 36 d. Okay, and then we have 10 by 6 is 60, and then we have 10 by 3, 10 by 6 is 60, by d it will be 60d, and 10 minus 3d by d is minus 3d squared by 10 minus 30d squared, minus 30d squared. Then we have plus 25d squared plus 18. This is S11. So we can collect all of them together. So we have 9d squared and 25d squared. It will be 34d squared minus 30d squared. It will be 4d squared. And then we have 60d minus 36d. It will be plus 24d. And we have 36 added to 18. It will be 54. 36 added to 18, it will be 36 plus 18 is 54. So now we got S11. Let's do the same thing here and the other form of S11. We will try to make here A, this by making A the subject. So S11 will be 11 multiplied by 6 minus 3d added to 55d. So it will be 66 minus 33d added to 55d. So the final form will be for this one. So let's delete this and write it properly here. So it will be 66 minus 33d, and then here it will be minus 33d. This is S11, so it can be written at the end as 22 plus 66, 22d plus 66 here. This one is 55, and here is 11. Okay, so it will be 66 minus 33. It will be at the end 66 plus 22d. And here we have 4d squared plus 24d plus 54. So we will equate these two of S11. This step, the next step is you will make here 4d squared added to 24d added to 54 equals to 66 plus 22d. Put them all on one side. It will be 4d squared. Here 24d minus 22d, it will be plus 2d, and then we have 54 minus 66. The 66 goes inside by negative, so it will be minus 12 is equal to 0. So if you do factorization, you're gonna find d is 1.5, and then you're gonna take the positive value of d, because it was mentioned that un or the nth term has a positive value. So by substituting 1.5 in here, 6 minus 3 by 1.5, 3 by 1.5 is 4.5, 6 minus 4.5, a will be 1.5 as well. So now we got the value of the first term and the common difference. D is 1.5 and a is 1.5 as well. So what we will do is, now what's required, we need to find U20. U20 is the value of finding a plus 19d. So U20 will be a plus 19d. So it will be 1.5 plus 19 multiplied by 1.5. So the final answer will be, if you calculate 19 by 1.5, 19 by 1.5 is 28.5. and then add 1.5, so the final answer will be 30. So the value of U20 is equal to 30. This is the final answer for the question, so it will be 30. So quickly, what did we do again? We took U4, which is A plus 3D is equal to 6, and then we made A as subject of the formula, so A is equal to 6 minus 3D. Then we took S11, we substituted N by 11 in here in this till we got an equation of 66 plus 22D, and then we tried to work again on S11 by the given formula here, U6 plus 18, U6 squared plus 18, so it will be A plus 5D all squared plus 18. Then we expanded this bracket, it's A squared plus 10AD plus 25D squared, and there is 18 out. So we replaced each A by 6 minus 3D, so it's 6 minus 3D squared plus 10 multiplied by 6 minus 3D multiplied by D plus 25D squared plus 18 to make S11 as one complete equation in D. So it's 36 minus 36D plus 9D squared plus 60D minus 30D squared plus 25D squared plus 18. So S11 at the end is 4D squared plus 24D plus 54. Then we equated the two values of S11, this value by this value. We made a complete equation in D. Then we factorized, we got D as 1.5. Then we returned it to this equation, we got A as 1.5. So now we know the first term and we know the common difference, so we can easily get U20 as it's required in the question. So we did it as 1.5 plus 19 multiplied by the common difference, which is 1.5 as well. So we got at the end the final answer is 20. The final answer is 30 in this question. So let's move to another question and see how will we do this point. Okay, here it's suppose 36D. If someone is working on these questions on the past papers, so you can make sure your answer is correct. Another question, the question says the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. So the first 48, your n is 48 and the other one is 36, but the summation of 48 is equal to 4 multiplied by the summation of 36. So let's first of all find the summation of 48. Summation of 48 will be 48 over 2 multiplied by 2a plus multiplied by 2a plus here 2a plus 48 minus 1d, and here it will be S48 equals 24 here 2a plus 47d. So this is S of 48. Let's find S of 36, then we relate them together. S of 36, it will be 36 over 2 multiplied by 2a plus 36 minus 1d. Here is the point of this one, so it will be 36 over 2, so S36 equals here 18 multiplied by 2a plus 35d. So we got now S36 and we got S48. So let's relate them together in one equation. So it will be S of 48 equals 4 multiplied by S of 36. So S of 48 is 24 multiplied by a, so let's write it here in a wider place. So it will be written in one line. So 24 multiplied by 2a plus 47d equals 4 multiplied by 18 by 2a plus 35d. So we will expand on the two brackets so we can find the answer. It will be 48a plus, if we multiply 24 by 47 here, 24 by 47, it will be 1128d equals to 4 by 18. It will be 72. 4 by 18 equals 72 multiplied by 2a, so it will be 144a, plus 72 by 35. 72 by 35 will be 2520. 2520 d. 2520 d. Put them all in one side, so here it will be 100 negative 144a plus 48a equals 2520 minus 1128 all for d as coefficients of d. So let's try to write it here in one side, all of them together. So it will be written as, here it will be 2520 minus 1128 by d. Here then we subtract and find what will be the final answer here. So we can relate a and d together, so we can solve. 144 minus 28, 144 minus 28, it will be here 144 minus 48, it will be negative 96a equals 2520 minus 1128, it will be 1392d. So we'll divide by 69, or 96, sorry. So negative a equals 14.5 d, so a is a negative 14.5 d. So now we got a relationship between them. We cannot find the value of a, we cannot find the value of b because there are no terms given in here. But we can use this as a relationship between both of them. So we'll get back to the question which is required to find the sum of the first 30 terms. So n is 30, and you can replace each a by negative 14.5d. So to find s30, what you will do is you're gonna replace n by 30 over 2 multiplied by 2a, which is 2 by negative 14.5, plus n minus 1d. N is 30, 30 minus 1 is 29, 29 multiplied by d, so it will be 15 multiplied by negative 29 here, so this is d, negative 14.5d, so it will be negative 29d plus 29d. This is S30, so you will find at the end that this and this makes 0, so 15 by 0 equals 0. So S30 is at the end, it gives 0. So again, what did we do? We took S48, we replaced each n by 48. We got this equation, S48 equals 24 multiplied by 2a plus 47d. S36 is 18 by 2a plus 35d. Then according to the given here, I equated S48 equals 4 by S36. Then we substituted what was given in the two equations till we got this relationship. Then we made a as a subject equal negative 14.5d. Then I replaced this relationship here and the value of S30. I got at the end the answer is 0. Let's move to one more question here. And this is the last question for today. The question says 2x plus 23 and 8x plus 2, and then we have 20x minus 52. All of these are three consecutive terms of an arithmetic sequence. Prove that the common difference of the sequence is 12. So since these are consecutive terms and arithmetic sequence, so they come after each other. So this one like a, then a plus d, then we have a plus 2d. So the relationship between these three terms is whenever, what happens every time it increases by d? It increases by d and then it increases by d. So if you subtract a plus 2d, the last one minus the second one, the answer will be d. And if you subtract the second one, okay, if you make subtraction for a plus d and a, the answer will be d as well. So the point is, whenever you subtract the last one minus the one before, it will give you d, and so on. So the difference between these is d. So what I will do is, I'm going to take this one minus this one, it will give me common difference, and then I will take this one minus this one, it will give me common difference. So let's apply this rule. It will be here 20x minus 52, this one minus 8x plus 2, all of this is equal to d. So 20x minus 8x, it will be 12x. Negative 42 minus 2, it will be negative 54, is equal to d. The second one is 8x plus 2 minus 2x plus 23 is equal to d. So it will be 6x, and then we have 2 minus 23, it will be minus 21 is equal to d. So since this one is d and this one is d, so you can equate these two answers together. So it will be this part, it can be done as 12x minus 54 is equal to 6x minus 21. So here it's 12x minus 54 is equal to 6x minus 21. So it will be 6x equals, if you take 54 to the other side, so 54 minus 21, the answer will be 33. So x will be 33 out of 6. So I think it will be 5.5. Yes, so the value of x is 5.5 after solving this equation. So now we got the value of x, but it's required to prove that the common difference, which is d, is 12. So you need to replace 5.5 in any of these two equations. Then if d is 12, it means your answer is correct. So I will take the second equation, which is 8 multiplied by 5.5, then plus 2. Sorry, it's plus 2 here. Then minus 2 by 5.5 plus 23. All of this is, suppose it gives me d. So d will be here 8 by 5 is 40, so it's 44 plus 2 minus 11 minus 23. So this is 46 minus 34, so the answer will be 12, which is the common difference. So now we got the common difference as what was required in this question. We proved that it's already, the final answer is 12.